right, everybody. Welcome to Tech Talk DC, the August edition, I guess. Today, I have Wing Vendeventer with me, and organizer of Tech Talk DC, and we're looking forward to hosting a talk by Matt Ratliff. Hi, Matt.
Hey, Noah. Hey, everybody.
How are things going?
Yeah, they're going great. I've had a blast trying to prepare for this presentation, and just looking forward to it, and looking forward to be able to share RAG with you guys, and just see how it works.
Yeah,
that was awesome.
Matt,
why don't you just give us a little bit of your background and what got you onto the track of creating this presentation?
Sure. Yeah, absolutely. So I started out in the industry in 1998 as a software engineer, and got my bachelor's and master's degree in computer science. I actually went back to get my master's degree because I was interested in AI, and that was in 2005. And of course, we didn't have the tools and stuff that's available now. We used MATLAB, and it was very interesting. I absolutely loved it. Took pattern recognition, natural language processing, all the classes, and absolutely loved it. And then got back into the industry as a software engineer. But kind of with the resurgence of generative AI, it's really re-sparked my interest in what I was learning and the projects and stuff that I worked on in school. And so I'm hoping to be able to kind of extend myself more into that direction and learn more about AI, because I mean, we see it all around us now. I mean, it's everywhere we go, everything that we do, we're surrounded by it. And so, especially as a software engineer, it's good to be able to kind of, honeycomb yourself into a field like this that's up and coming.
So you've been trying to honeycomb then into more direct AI work?
Yeah, absolutely. Probably over the last few months, I've been working with some of the folks there at Excella, and including Dohan, to be able to kind of extend my knowledge and be able to start helping out in the Gen AI and the whole AI industry, at Excella.
So
I'm really super excited about it.
From like a software engineer's perspective, are you seeing that there are a lot more sort of opportunities to get into it now? Because obviously LLMs are blowing up and everything, but typically with AI, you needed to kind of be specialized for a while before you could really like practice it. It was you're either like a data scientist or like a PhD algorithm guy. So
that's it. I mean, it's basically in 2008, the path in AI was basically you created a thesis, which I have a thesis, but that the path was you go straight into a dissertation and you become a PhD. And so I didn't have the opportunity to explore that at the time, but like you said, I mean, the applications were out there, but we didn't have the framework to support it at the time. It was still mostly academic. And so I had originally wanted to go on and get a PhD and pursue that route, but I found myself in the software development industry. And now I'm glad that I did, because now we can marry the two. I can marry what I've done in software development, as well as go back and kind of retrain on the skills that I had in graduate school and what I've learned thus far in AI in the industry.
Yeah, I think that's what's really interesting thing about RAG is you're able to apply all these software engineering skills to it now. So much of it is
exactly
engineering the whole solution, where maybe a piece is using the actual model or models.
Exactly. And that's exciting.
Exciting for the opportunities for software engineers. Yeah,
it's very exciting to get into it, because like you said, I mean, as a programmer, you have the integration knowledge to be able to hit an API and build a web application. But now you can build a web application and have the power of RAG or NLP behind it to build not just a proof of concept, but a fully fledged application that can be used.
Right.
All right. Well, without further ado, let's get to our presentation, Matt.
All right. Thank you. Appreciate it. Hi, everyone. Welcome. I'm glad you can join me. We're going to talk about RAG, retrieval augmented generation. what it is, how it works, and what problems it solves with natural language processing. So I'm going to leave about 10 minutes. I'm going to try to, leave about 10 minutes or so for questions at the end of the presentation. Okay, let's just go ahead and get started. So just to give you a little bit more background, my name is Matthew Ratliff, and I'm currently a lead consultant at Excella. Excella is a technology consulting firm based out of Arlington, Virginia. I'm currently a member of the innovations team at Excella, having Microsoft Certified Professional and Agile certifications. Currently working on an Azure AI engineering certification that I hope to complete this quarter. I've been in the technology industry, like I said, since around 1998, working in a wide variety of industries, wearing several hats throughout my career. I first became interested in AI around 2005, like I was, telling you all earlier. I was working as a software engineer and became interested. And that led me to be able to finish my graduate degree in computer science from the University of North Carolina, Wilmington, as well as speaking at several conferences, including the IASTED conference in Innsbruck, Austria, on the topic of emotion recognition from facial expressions using active appearance models. I've worked in the industry, in the gaming industry as well, and several others. So like, for example, while working at Red Storm Entertainment, I contributed to the development of Ghost Recon Future Soldier, the Xbox game. And there I was able to contribute to the multiplayer platform, assisted in physics and simulation, as well as several AI-related features. So I'm here today to talk about recent advancements in NLP, specifically RAG. So as the industry grows, we see more and more companies realize the potential of the data that is generated from their applications, as well as the potential uses for AI in a wide variety of uses within a company. The birth of Gen AI has provided an opportunity for AI to become incorporated with business processes and to improve workflows, task automation, and information processing. So we'll start with a brief background of where RAG started that led us to where we are today. Then a discussion of what RAG is, the current problems of traditional RAG models, and how RAG can be used to solve those problems. Then we'll discuss the inner workings of the RAG framework, breaking down the components and demonstrating the workflow. And then to wrap it up, I want to give a demo of a RAG implementation that I built using LangChain and OpenAI, just to demonstrate how it works. So to start with, what is natural language processing? Natural language processing is a term that we've all heard and had some idea around what it is. But to understand the need for RAG, I wanted to provide some background and foundational knowledge. So NLP is a field that attempts to improve upon how we communicate with computers through text, video, and audio. By being able to provide systems with the ability to communicate with humans using speech and text, we can improve the way that we interact with them. Of course, the ultimate goal is to have a system that generates conversation that's indistinguishable from that of the human. So Alan Turing in 1950 imagined this by creating the Turing test, which several of you have probably already heard about. It's a test to test a machine's ability to exhibit intelligent behavior equivalent to or indistinguishable from that of a human. One of the main goals of NLP has always been to create a human-like conversational system. Up-to-date and accurate domain-specific knowledge is one of the greatest issues that NLP has faced. We will see that large language models and techniques such as RAG help us to get one step closer to that goal. So NLP has several facets, including text-to-speech, language understanding, language generation, language translation, and conversational agents, just to name a few. Language understanding uses techniques such as tokenizing and sentence parsing to break down sentences grammatically to their base components in order to better understand the meaning of the sentence. Language generation is used to generate speech from text. Like traditional speech-to-text systems currently use this. Language translation is another category of NLP. From one language to another, translation from one language to another, it can be difficult due to like being able to map semantic meanings across languages, not to mention the overall structural difference between groups of languages, such as Germanic languages versus like Chinese or Japanese. Applications include chatbots like we've seen in ChatGPT, Claude, Meta, and several other chat systems. So let's talk about the way traditional language models work. In a traditional model, the LLM, or the large language model, is pre-trained from a knowledge source. The data that we use to create a LLM is known as training data. Training data is the relevant data that a system uses to best approximate a good response to a user's query. So to start with, a user just asks a simple question. So, how often should I exercise? A prompt collects the question, generates a query to pass to the language model. The LLM, or the large language model, seen in the diagram, represents a model that contains the trained data used to generate a relevant response. LLMs are significantly different from regular models, I'm sorry, not significantly, but slightly different from regular models, just due to the size of the training data used and the overall scale. The model then uses a similarity metric, such as clustering, with the distance metric, just as a simple example, to determine the most relevant content based on the query. Other algorithms, such as the statistical methods for principal components analysis and support vector machines, can also be used to assist with data grouping and classification. So the model generates a response from the retriever and generates the output. We'll talk more about the retriever as we discuss RAG, but in essence, it queries the LLM for relevant data and then generates a response. So as mentioned in previous slides, LLM differs from a traditional language model just due to the size, the number of parameters, and the amount of training data used to create it. Systems, like I said before, ChatGPT, Claude, Meta, and BERT are just a few of the systems that use LLMs. OpenAI and Hugging Face are a couple of examples of companies that produce LLMs from large amounts of training data across several distributed sources. LLMs, as seen in the diagram, pull source data from a wide variety of different places and contains a variety of different formats, including PDFs, Word documents, JSON, and HTML content, and several others. So training a large language model. When I say train, this process is referring to identifying good data sources, formatting that data, and applying an algorithm that can best represent the training data. The data is formatted and passed to an algorithm that is used to build a representational model. The training can consist of unsupervised learning, such as a neural network, is like we can see in the diagram. Human feedback can provide tags for labeling the training data. And they all basically all work together to generate a model that represents the actual training data that was provided. Okay, so we've talked a little bit about NLP and some of the stuff going on there. So let's talk about RAG. So what is RAG? It's simply retrieval augmented generation. So let's break it down and talk about it. Retrieval retrieves relevant data from external knowledge sources. Augmented augments the retrieved data sources outside of the LLM and combines it with the LLM. So we can see augments and then current data source. Those are highlighted because they're specific, and we'll talk more about those in the future slides. Generation produces the response from the augmented LLM, which is like what I said before, which is what the existing NLP models do currently. But a point to note is the retrieval and the augmented part of this. So before we dig into it, let's talk about the problems with traditional models. Limited knowledge scope. So generative models struggle with generating accurate responses on rare or domain-related topics, especially if these topics are underrepresented in the training data. This often results in vague, incorrect, or even fabricated information. Inability to handle rare or niche topics. Without access to external content, models can produce irrelevant responses, especially in complex or conversational workflows where maintaining context is crucial. Memory limitations. So traditional language models have a finite memory capacity. This makes it difficult for models to recall specific details over long texts or complex conversations. Hallucination of facts is another issue. Generative models sometimes hallucinate facts, producing information that sounds plausible, but is actually incorrect or fabricated because the model is trying to generate responses based solely on just the limited training data. Scalability issues. So as generative models grow in size, they require more computational resources for training. This makes them expensive to run, especially when needing to frequently update the model with new information. Difficulty in task adaptation. So traditional models require fine-tuning on specific data sets for different tasks, which can be resource intensive and limits the model's ability to new or emerging tasks. And lastly, inadequate handling of ambiguous queries. So generative models often struggle with ambiguous queries, generating generic or non-specific answers due to the lack of domain knowledge or context. So with current models, responses are limited to the training data used to train the model initially. Responses in those cases can be very generic and vague, and sometimes provide incorrect answers depending on if the training data is stale or out of date. So how do we fix this? We currently need a way to determine outside sources, or we need a way to determine outside sources. So in traditional systems, the model is trained once, only once, with no new influx of information. We need a way to be able to update the data source so that the model can provide accurate responses without the need to be retrained. We also need a way to integrate external knowledge with the existing large language model. So if we were to gather external data, how then could we augment it with the current existing model? And then last, assuming we can integrate it with the existing model, we need to find a way to format the response using the combined data sources in a meaningful way. So RAG addresses many of these issues, as we'll see in upcoming slides. So let's talk about the components that make up a RAG architecture. A RAG system consists of the user's prompt, used to collect the question or statement from the user and generates a query. The language model, which is pre-trained on all of the relevant data, is used by the system to generate an appropriate response. The indexing system, which is the part that occurs before the query is ever made. So this is used to take the external data and format it in an efficient way so that the document retriever can better and more quickly access it. The document retriever retrieves the data from the vector store where the document data resides and uses an algorithm to generate a meaningful response. And the vector store houses the indexed document data. So these are the basic components. And next, we'll see how these components work together to complete the workflow. So the indexing stage is the first stage that happens before the user makes a query. Data sources are identified and data is extracted using a document loader. The data is then split into meaningful chunks, indexed, and stored in the database. So like I said before, this stage is done in advance of the query so that the vector store is ready to be used by the system when a user asks a question. So we start with the document loader, which is used to load different types of documents. Most systems have several different types of document loaders available. LangChain, for example, has an extensive list to choose from. The document loader pulls the data from the source in a wide variety of different formats, such as JSON, PDFs, Word documents, HTML markup, and so on. So next, the document loader passes the raw document data to the text splitter, which chunks the data into meaningful chunks for better searching. This text splitter is also known as a chunker as well. The overall size of some documents make it difficult to search without some type of pre-processing. Chunks can be customized by the size and number of chunks that you prefer based on your application. The size and number of chunks can affect the retrieval speed of the information from the vector store. Next, the splitter breaks the chunks, passes the chunks to the embedder, which provides a vector of the chunk based on the content. Chunks of similar content will have more closely related vectors, as we'll see in a future slide. Providing a vector index will allow the retriever in the query process to quickly search for the relevant documents based on the user's query. The index chunks are stored in the database, which is now the fully complete and processed training data that the system can use in conjunction with the LLM to provide a better response to the user. Okay, so the querying stage. Now let's move on to that. As I mentioned before, the indexing stage processes the external knowledge sources into the vector store in preparation for the query stage. Once the indexing is complete, the system is ready to take a user's request. So we just start with a simple question. How often should I exercise? Or how do I do this? Or just a question, just to start the process. The question is passed through a prompt, converting to a query and passing to the embedder. The reason for passing it to the embedder is that the embedder is responsible for indexing. The embedder will vectorize the query. Once the query is assigned a vector, it can be used to make a comparison against the pre-existing vectorized chunks from the training data. The retriever uses an algorithm to identify the most closely related chunks to the user's query based on some type of similarity metric. The chunk data is retrieved, formatted, and then augmented with the original query to pass to the large language model. The LLM uses the retriever response and produces a more accurate response than what the LLM could produce alone. Hopefully, it should. Okay, so how does a retriever work? The retriever uses a similarity measure to find the most relevant documents from the vector store. As we can see in the simple 2D example, the vectors are assigned to the document chunks. The chunks are then organized based on their similarity. The clustered documents in the upper right quadrant represent documents that contain similarly related content. So the query vector passed from the embedder to the retriever is plotted against the existing chunks in the same dimensional space. An algorithm, such as k-means clustering, will cluster groups of similarly related chunks. Once the chunks have been identified, another algorithm, such as k-nearest neighbor, can then be used to measure the distance to each cluster and decide which is most relevant to the user's query. So as we can see in the diagram, the cluster in the upper right quadrant is more closely related to the actual query vector because of the distance measure that was taken. 0.09 is closer than 2.2, for example. And so the system would naturally take the documents in this cluster and return it back to the system. And this is just a simple example. I mean, there's several different types of classifying and grouping algorithms that can be used. Okay, so I wanted to provide a really simple RAG demonstration just to show you how it works. So I kind of toyed around with what I could ask it just for a simple demonstration that it doesn't know in order to augment it with external knowledge. And so what I did was I asked ChatGPT-4, what are the references from the emotion recognition paper presented at the IASTED conference in 2008? This is the paper that I wrote and presented, but may not be available to the trained LLM for on ChatGPT. So this is very specific information. In order for LLMs to be trained on data that specific, they would need an insurmountable amount of data. Also, searching for something so specific with that large of a data set would take a lot of computational time and expense. So ChatGPT responded with, I would need specific details from the paper or access to the paper itself. So if I were to provide the white paper from the presentation, then hopefully it would generate a better response. Okay, so we're going to use the paper that I wrote for the conference as an external knowledge source for the RAG implementation. So this is the external knowledge source document that we're talking about. I chose to use LangChain with OpenAI and Facebook's FAISS. It's an acronym. I'm not exactly sure if you say it as one word or an acronym, but I'm using it as an acronym as the vector store for this demonstration. So let's move over to the development environment that I used, and we will run the demo. Okay, so I created my RAG using Jupyter Notebooks just for the simplicity of the presentation. Jupyter Notebooks is a nice development environment that data scientists commonly use to build and test their data solutions. In order to save time, I've actually pre-written the Python scripts needed for the different stages. I'm not going to go into too much about the LangChain API.
Matt, would you be able to zoom in a little bit?
Sure, absolutely.
So we can maximize visibility. Thank you.
Yeah, absolutely. Yeah, like I said, I pre-wrote this just so that way to save time. But I'm not going to go into too much detail about the actual API, LangChain API that I used. But I can tell you LangChain has some great examples and documentation that you can follow if you're interested in learning more about it. Okay, so first thing, we need to install the Python libraries that we want to use. And from the research and the documentation from LangChain, this is what I chose. And so what you do is you just click run. And we can see the asterisks in Jupyter Notebooks indicates that it's processing. So when it gets finished, it'll revert back to the index. Yeah, there we go. So I've run this before, so it basically tells me that the requirement has already been satisfied. So it's already installed the needed packages. So we'll go down to the next step. So the next step is basically to import the classes that we need for in order to from the packages. And so, like I said before, these are the classes that I chose to use for the demonstration. But like I said, also, LangChain has great documentation for this. So, feel free to go over there and mess around with it and create your own. All right, so let's click run. And that went through pretty quick. All right, so now we have the classes that we need. So the next step is the indexer, like we were talking about. So the document loader step. So what this is going to do is this is going to access my external document from the conference paper, from the conference. To start with, you have to I provided my API key to OpenAI to be able to access the LLM. The model that I'm choosing is ChatGPT-4, and I'm providing it the document. Now, this is just a single document, but typically just for the demonstration, but typically what you'd want to do is provide a group of knowledge sources, a group of documents to provide the best chunked data that you could in order to improve the response. All right, so we're going to call the load method in order to get it says documents, but like I said, this is a single document. So click run. All right, so now what we can do is we can actually examine my documents and just see where we are in the process and make sure that it actually has what we expect. Okay, so what we can see is this is an array. It's an array of document objects. containing metadata, and also the actual page content. So it actually has loaded the document that we would like. So we're successful thus far in the process. So the next step is to pass that to the text splitter or the chunker. So I import the character text splitter from the library, and actually split it into chunks. It takes a few parameters. Chunk size is one of them. It's just the size of the chunks, as well as a chunk overlap. I'm not going to get too much into that, but chunk overlap is the actual amount of overlap that you want between the chunks. That can improve the overall response in a lot of cases. Okay, so we're going to go ahead and pass documents into the splitter. Okay, that's done. Now the last step is to actually embed it. So we're going to use OpenAI embeddings and pass what we've accomplished so far with the text and the actual embeddings into the vector store. So what this will do is this will actually create a vector store that actually has their chunked index data. Okay, so now is the actual query stage that we talked about. Well, no, I take that back. We actually have to create the LLM first. So we're going to use OpenAI to create an LLM from what we chose. This is the model, Chat GPT-4. So we're going to create the LLM, and I just want to mention this really quickly. So this let's see, this one, conversation buffer memory. So if you're building a conversational agent that requires back and forth conversation, this is nice because the system can actually go back to previous conversations and get more context out of it and better understand the context for the question that you're asking. So like I said, it's not really needed in this case because we're just asking one question, but this is a nice little feature. Okay, so we have our LLM, we have our vector database trained on our chunked embedded data from the paper. So now we're going to ask the same question. So this was the question that I originally asked ChatGPT before. So one of the references from the emotion recognition paper from the IASTED conference. So what we're hoping is that it'll produce something a little bit better than just saying it doesn't understand or it needs the paper. Okay, so this is the time where the actual retriever does its magic in sifting through the index embedded chunks in order and augmenting it with the LLM in order to create the best response. And there it is. These are the citations and references from the paper. So we can see that providing external knowledge sources and augmenting it to the LLM can provide better contextual knowledge and overall responses. Okay, so yeah, that pretty much concludes the demonstration. So let's flip back over to the presentation. Okay, so practical applications of RAG. So we've talked about how RAG works, dissecting the architecture and walking through a simple RAG application. So let's talk about some of the practical applications. Conversational agents or chatbots is now being seen across many domains in the industry. It's really interesting though, because as I was preparing the presentation, my son Chase texted me this morning and told me that he was amazed that he went through the Bojangles drive-through and a chatbot took his order. And I asked him, I said, well, that's awesome. I said, did it do it correctly? He said everything was correct, but it missed the water. It missed his drink. So, but it's amazing. It's a great example of chatbots becoming more prevalent in integrating into our everyday workflow. All right, so moving on to content creation summarization. This is another RAG application. Researchers, students, and industry professionals can leverage RAG for up-to-date relevant content specific to a domain. Education can use RAG-powered AI systems for various tools and resources, promoting learning and advancement. And even the legal field can utilize RAG for legal and jurisdictional and other related documents that could pertain to a case. So chatbots can be used in any domain where specific knowledge is required. RAG can be used to power customer chatbots or virtual assistants that can provide accurate answers by retrieving relevant information from a company's knowledge database or documentation. A chatbot can leverage RAG to recommend products and by retrieving and summarizing information from product descriptions, customer reviews. So when a user asks for a product suggestion, the chatbot can generate recommendations based on the most relevant products available, as well as recently purchased products. Also in travel, chatbots can retrieve information based on flight schedules, hotel availability, and travel advisories. Content creation, RAG can be used for fact checking when writing an article. For example, RAG can be used to pull the latest scientific articles for research findings and keeping information up to date. When writing a blog, RAG can be used to query the latest information to ensure that the writer has up-to-date information. Research papers can be enhanced by fact-checking against white papers and other research documents. And like specific case studies in knowledge articles can be pulled in to enhance a research paper, for example. Educational tools and resources is another one. Interactive learning assistants can provide students with tutoring and learning objectives, as well as assistance with homework for looking at facts and how-to guides. Research assistants can help researchers find facts and relevant information on research topics, as well as assist with generating and formatting references for research paper. Also, RAG can be used to augment learning through test preparation. A question and answering system trained on documents specific to the learning objective could be used, as well as preparation for tests by the generation of practice tests. Legal, RAG can be assisted in the legal field as well by searching through large amounts of legal documents, ensuring that any legal document generated has the latest up-to-date information regarding laws and regulations. It can help to prevent hallucinations and incorrect information, which can be detrimental to a field like law. Legal document summarization is another way that RAG can assist in the legal field. A legal team preparing for trial, for example, could use RAG to generate summaries from hundreds of deposition transcripts. Documents can be analyzed comparing laws across different jurisdictions. Lawyers or paralegals could use a RAG-powered system to get answers to legal questions about procedural rules. Basically, any industry or domain that requires privacy can utilize RAG, since RAG's knowledge sources are not required to be public-facing. Domain-specific information can be kept private with the RAG solution. So some of the challenges that we face are similar with RAG in addition to NLP models. Data retrieval takes time depending on the complexity and number of chunks. For example, in this demo, there was only one document, but even then it took a little time to process. Also, if the chunks are incorrectly related, then the embedder can produce incorrectly chunked by the embedder, then it will produce inaccurate responses. The overall size and number of documents can also slow down the system, even after chunking and indexing. Also, documents can be outdated. For example, if you're building a RAG chatbot system using company documents, if those documents are incorrect or stale, that will affect the reliability of the response. Also, hallucinations are another factor to consider. Responses can return with a high level of confidence and still contain incorrect data. So as we think about ways to prevent stale data, we can consider an architecture like FLAIR to improve the RAG workflow. FLAIR stands for Forward-Looking Active Retrieval Augmented Generation. This is a method that was introduced in 2023 paper titled Active Retrieval Augmented Generation by Jimpo Zhan. The original implementation can be found in the paper's GitHub repo, which is referenced in this presentation, and also which the LangChain implementation draws heavy inspiration from. It enhances the ability of the large language model by retrieving information from external data sources during the generation process. It also helps to reduce hallucinations and inaccurate information by using on-the-fly smart query of the data from external knowledge sources. When the model is uncertain about the response generated from the LLM, the receiver will search the external knowledge sources for more up-to-date missing information. Okay, so the part circled in red is basically the part of the flare that extends the traditional RAG model. As we can see in step 2, the query is passed to the search agent to search external knowledge sources. It does this by highlighting the parts of the response that is in question coming from the LLM. The LLM can then generate a question from the highlighted parts that can then be queried, then it can then query the knowledge source for. So it basically does a search. I mean, it's kind of like what we do, when you're looking up something and there's something that you don't know, and there's parts of it that you don't know, and you go out and look for it and try to rectify it. And that's pretty much what Flare is doing with this. It's recognizing, the LLM recognizes there are things that it's uncertain about, so it can on the fly go out and search for knowledge sources.
Matt, we had an audience question. What happens
Sure.
if one of your references in your demo example is split across 2 chunks? This is from Larry.
That's a good question. That was one of the things that I wanted to explore a little bit. I didn't really have the time to dig into it, but I wanted to provide like multiple documents and explore chunking a little bit more just to see kind of how it would react. I'm not really sure, to be honest with you, but that's a great question.
Great questions are how we learn. So
yes, exactly.
We had
Yeah.
another question from Will. Can you
Okay.
elaborate on what governance is needed around document management to ensure accuracy?
Well, that's a tricky question because when I think about like HR documents or documents within a company, it's really human error that can create like inaccurate documents. So that's one weakness that we have, is the fact that the human element creates documents, but that does not. There's no guarantee that it's necessarily accurate or contains correct information. And so that is actually one failure that's still in the system, that's still in the workflow, is the fact that the knowledge sources may or may not contain accurate information. So it's really up to the company, like if it's for a company, for example, just to make sure that knowledge sources are double checked and nothing is actually provided that that RAG could pull from in order to corrupt the ability for it to give an accurate response.
Got it. Also, as you were talking about that, I did think about something. So if you have to chunk, if the document is large enough that it needs to be chunked, and I mean, I don't know the answer to the question itself either from a RAG perspective, but fine-tuning the model itself might be more appropriate. If you have a whole bundle of documents, then the model would be able to reference everything in one go.
Yeah, absolutely. That's, like I said, that's something I want to explore a little bit more. Is the actual? I mean, there's a couple of stages where the system could potentially break down. I mean, because the machine learning algorithms that you use in this process, it's really dependent upon, it depends upon the algorithm that you use, because the retrieval mechanism, for example, like I said, I just chose like a k-means clustering and nearest neighbor, but that's kind of within the realm of data science of choosing the best machine learning algorithm to be able to make the best choices. It's the same thing with the embedder and the chunker. How you chunk it and the way that the embedder chunks is it actually can play into the process of how successful you can generate a response.
All right, thank you. Well,
yeah, absolutely. Yeah, sure, absolutely. Okay, so Flare uses a prediction. This is interesting. It uses a prediction of the upcoming sentence context in order to create a query to retrieve the relevant documents from the external knowledge source. So Flare doesn't necessarily, it doesn't do a search on every single query. It only does the search on the fly when the LLM produces something that is unsure of the authenticity or the accuracy. At that point, it can trigger Flare to go out and dynamically query the knowledge sources for more information to, to hopefully rectify the question. Okay, so in conclusion, RAG improves the workflow by augmenting domain knowledge with the existing LLM. It reduces the likelihood of incorrect, inaccurate, or hallucinated information by providing up-to-date and relevant information. It can produce better results using a wider range of user queries. It assists LLMs by providing accurate information without the overhead cost or retraining the existing model. And here's the list of references that I used. They were pretty extensive. So, but here's the thing: there's a lot of really good information out there that you can find on this stuff. And so, I would highly recommend if you're interested, just dig in. Like for example, if you're interested in like what LangChain can provide, they have great documentation. You can use Hugging Face. So there's so many different routes that you can take. And that's kind of the way this industry is now. Everything changes all the time. There's always new advancements, and so you have to stay at the cutting edge. Otherwise, the knowledge that you have, it gets stale, fairly quickly. And so I would encourage you to to just get out there and experiment and just try some stuff. And as Dohan said, that's how you learn. Is something you don't know, then you go ask for it and you query it.
Would you mind copying those references into the comments section?
Yeah, absolutely.
Thank you.
Sure. Okay, yeah, and with that, that pretty much concludes the presentation. If there are any questions.
Yep. If you're listening on YouTube, use the YouTube comments to ask your questions. If you're listening on x.com, please just reply to the post, and I'll relay the question to Matt.
Now the question is, can I find the window for the for the video?
Matt, I had a question. If you're like an organization and you're interested in pursuing building a RAG application, what are some of the like sort of business considerations as far as like what kind of cost is it, to build a RAG application? And like if you want to do something, the feasibility, you think, okay, I want to. This is really promising technology. What can I really expect as business wise, productivity wise for some RAG application goal? Like, can I get it to really impact productivity for like business documents internally or something?
And that's one of the things that we're exploring right now at Excella. We're working on a chatbot system that basically can sift through HR documents and try to find HR related information. So it's a great question. And, companies, any industry that has domain specific knowledge can utilize it. It really just depends on how much knowledge sources that you provide, how many documents and how accurate the documents are that you can provide. So like, for example, with HR documents, if people want to know, like, when are the holidays, or, what's the best, anything that an HR document could provide, like even timesheets, like how often should I submit my timesheet, anything like that, you could provide those documents to the system. And, you could create something like maybe a Slack bot, or, tied into Teams, or there's lots of different types of integrations that are supported now, where you can implement something like that in such a way that if you were to ask Teams or SharePoint or Slack ask the question, and you could employ your RAG application there, and it could actually answer your questions for you without having to go back to HR or sift through hundreds of conversations and Slack history trying to find the answer that you're looking for.
And just a quick clarification there.
Yeah.
And I'm only saying this just because I mentioned fine tuning before. When would you use RAG versus fine tuning? And I did ask Claude before asking you, so I do have a backup answer.
Oh, there you go. You're trying to stump me, which is not hard to do. Well, I mean, when RAG uses external knowledge sources, and so it really depends on the content that you put in the documents. But I guess in a situation where RAG doesn't generate the responses that you're looking for, in that case, you could fine tune it to generate a more accurate response. So, like for the references that I asked for, maybe I'm not necessarily looking for just the list, but maybe I'm looking for a better response than just the list of references. In that way, I could, you can adjust the knowledge sources, or like you said, you could fine tune it. And fine tuning, is a lot of that is human oriented as well, by going in and labeling training data and kind of guiding the training process.
Yep. Yeah. So and I'll just cover Claude's answer here. So when you have a large and dynamic knowledge base that frequently changes or updates, RAG is appropriate for that. Also, tasks requiring extensive external information, reaching, perhaps internet searches and all that stuff. But fine tuning is for specialized tasks or domains where you want the model to develop deep inherent understanding, which will result in faster inference times, as in faster response times, and better performance and privacy, because then the model itself can operate in a offline mode. So those seem to be the differentiators.
I would be really interested to see how that fine tuning would actually play out, like how you would implement that in a RAG system. That's really interesting. But no, that's a great idea. I mean, because it's not going to be perfect in every case. I mean, because of the fact that sometimes you may want, like you said, you may want more specific information rather than just what it can extract out of the knowledge sources.
Yeah. When you were going to ask something.
Just getting into like the costs a little bit. So if I'm like a business and want to maybe do this HR thing, and say I'm at like a enterprise size organization, so a fair amount of data, I guess, to feed through the RAG system. Like what kind of costs am I looking at? Like, is it like cheap these days now? Is it like not something that can be concerned with, or is it very expensive?
Well, I think the what I've experimented with thus far, what I've seen is the cost for basically querying the large language model. So like OpenAI, for example, it will charge you based on your usage. And so it really depends on how often you use it. The actual building of the RAG, I mean, is pretty much free. You can build it yourself. The knowledge sources, are already within the company's domain, so that's already available. But it's really how often it's used. So, I mean, you can use an OpenAI source like that. You can use OpenAI, or you can even go with something like Azure or AWS. And of course, they have different cost tiers based on usage. So I think that's probably the main contributor is how often it's used.
Those will be more expensive for sure.
Because absolutely.
Like Azure OpenAI, for example, makes you reserve a capacity. So like the minimum spend on it would be $150 a month, whereas to spend $150 a month on OpenAI for example, their platform.openai.com, you'd have to try very hard to get there.
Yeah.
So.
Yeah, I think I spent like $10 for OpenAI, just to start with. But I've used it for a week, and I'm still going pretty strong with my API availability for it. So yeah, I can definitely see that.
Yeah, and that $10 is OpenAI makes you now pre-purchase like a prepaid card, prepaid AI card, and then you use towards it. I'm sure if you check the balance of it, you've probably barely spent $1.
Wow. Yeah, that's something that was interesting. I haven't really gone back and looked at it yet to see how much I've actually spent. Yeah. But I've used it quite a bit over the last week. So I'll have to go back. I have to go and check and see.
Yeah.
So very accessible then for companies to start trying it out.
Oh, absolutely. Yeah, for sure. In one day I was able to implement, go through lane change documentation and figure out how to build RAG just through their examples. And it's very, very low barrier of entry. But yeah, it's just the cost of actually using the large language models is where it starts to come into play.
Right. So some considerations when starting to scale.
That's it. Yeah, it's based on scale. Yeah.
All right. Well, thank you very much, Matt, for joining and presenting all you have learned and discovered about RAG. It was a very interesting talk, and it was also very interesting to see that you don't even have to do much formal coding. You can just use something like a Jupyter notebook to experiment, and of course, if you don't exactly know the Python or what have you to use, you can use ChatGPT to have it write the code for you.
Absolutely. Yeah, you absolutely can. And it will. It's so interesting because one of the shows that I really like is called Bloodlines. It's on Netflix. And so the ending, well, not the ending, but during the show, one of the main characters died. And so I always thought, well, it'd be interesting to revive that character and just say, well, what happened if they didn't actually die and they came back? So I was just goofing around and I asked ChatGPT, give me a scenario, a spinoff of this show where this character didn't actually die. And it actually did. It generated like pages of documentation of really detailed background information about how this person, faked their death and all of this. And I was like, wow, that's very impressive. I really had no idea that it would go to that level of depth.
Yep. All right. Well, thank you so much. And thanks to everyone for joining. Everybody have a great rest of your Wednesday.
Yeah. Thank you all.
Bye.
It's been a pleasure.
Bye.